All right, so this is continuing our series of final exam prep. Sorry, my neighbors are doing construction. So here we go. So for the following series, determine if the series converges absolutely, or conditionally, or diverges. Okay. So this one, right, they're all going to be positive. So we're not talking about alternating series, which is where you would want your, converges conditionally or absolutely. Okay, so let's check this one out. So let's see here. Where's my little pen? Here we go. So we want, okay, n is equal to 1 to infinity, 2 to the n over n squared. Okay, which one's going to get bigger or faster? Okay. So if I just try limit, right, as n goes to infinity, we end up with a 2 to the n over n squared. Both of these are going to infinity. We end up with infinity over infinity. Okay, so that doesn't really help because that's not something I can figure out. Okay, we might want to apply, right? We might want to look at, say, 2 to the x over x squared and see what's going on with that, and wonder if I can't use L'Hopital's on this thing, right? So this is going to be 2 to the x times ln x, or ln2 rather. That's the derivative of 2 to the x. The proof for that, or demonstration I should say, right, is going to be e to the ln of 2, right? That's equal to 2 raised to the x, and then we just multiply that. So that's e to the x times ln 2. So the derivative of this, right, is e to the x ln 2 times natural log 2. This is going to go back to being e to the ln 2 to the x times ln 2. E to the ln 2, that was 2 to the x ln 2. Okay, so if you don't remember that rule, that's a way for you to kind of, to get it without having to remember this thing. I never remember it. But divided by 2x, so, well, the limit's still infinity over infinity. So let's use L'Hopital's again. So we end up with 2 to the x ln 2 twice, right, divided by 2. Now when I take this limit, right, this goes off to infinity, and we don't have to worry, right, because x goes to infinity. 2 to the x ln 2 squared over 2 diverges. We don't have to worry about this anymore, so this diverges. Right. I'm sure there's other ways to do this. I'm sure you could use ratio test. Okay, if we did ratio test on this, we could say this is 2 to the n over n squared, right? And then apply our ratio test. So it's going to be 2 to the n plus 1 over n plus 1 squared times n squared over 2 to the n. Right? And then let's see here. This is going to cancel with one of those. So we have 2. We have 2 squared over n plus 1 squared. As I'm taking my limit, right, as n goes to infinity here, then we pretty much have a, right, we're going to multiply by 1 over n squared, 1 over n squared. So we have 2 times n squared over n squared, which is 1. Then we have n plus 1 over n squared, right? Because I can do that with exponents. It's 2 times 1. That's going to be 1 plus 1 over n squared. As n goes to infinity, that goes to 0. So our answer is 2. Since the limit's not 0, right, diverges. So, okay. Now, the next one, like part B, we have to, where we have a negative, we have n is equal to 1 to infinity. We have a negative 1 to the n plus 1. We have 1 plus n over n squared. Let's see here. I know I wrote this one down a little bit before I did it because there's 2 conditions that we have to deal with here. So we're going to use alternating series tests because we have alternating series, right? So what we're going to do, -1 to the n plus 1. Okay. And then what do we have here? We have 1 over n squared plus n over n squared. Okay, because that's what you can do with the fraction. So that's 1 over n squared plus 1 over n. Okay, as I take my limit, as n goes to infinity, right, that's going to be 0 plus 0. So my limit is 0. Okay, so the two conditions we need, right, for does it converge like this? So what we're going to do is we have to check, right? We have to check. Does the limit equal 0? Yes, it did. Okay, this is for alternating series. And 2, is it a decreasing function? Okay, so one way we could do that, right, is we could assume that the function, right, 1 plus x over x squared, we could see what the derivative is here. So f prime is going to be derivative of the top, 1 times the bottom, minus the top times the derivative of the bottom. It's quotient rule, right? Or divided by x to the 4th. Okay, so we have x squared minus 2x minus 2x squared, x to the 4th. So that's x squared minus 2x squared. That's 2x minus x squared over x to the 4th. That's minus 2x minus x squared, or 2x plus x squared rather, over x to the 4th. For my x greater than 1, right, because that's what we care about, because it's dealing with ones. Okay, so for x being positive, this is decreasing. It's always negative. The derivative is always negative. It's a decreasing function. So is it a decreasing function? It sure is. So because the limit was 0 and it's a decreasing function, we're going to converge by alternating series test. So converges alternating series. Okay. Does this converge? If I just have absolute value, if I just pick this one up? Well, this is 1 over n squared. That part converges, but this is 1 over n. 1 over n is harmonic series, right? That diverges. So the absolute value of this thing does not converge. Okay, the absolute value of this thing diverges. So it does converge, but only because it's an alternating series. Okay, so that's what we have for that one. All right, and as usual, I'm going to part this out by different pieces here. So let's go ahead and stop recording, and I'll hit you in the next one. All right, very good.